Okay, so today we're going to continue talking about factoring trinomials, but now we're going to look into a trinomial that looks a little bit different than the ones we've been working with. So I want to first take us a little bit back to the multiplying part. So we've been working so far into getting answers that look like this, right? Something like x plus 5 times x plus 3, or x minus 2 times x plus 7. Those have been the answers we've been getting so far. So let's remember, if we go back and create our area models here and here, put our x in our 5, x in our 3, and do this multiplication. Okay, and then I'm not going to finish filling that one out because I'm going to make a point here. And this one would look like x minus 2 and x and 7. So when we form these area models for this, we end up getting an x squared in both of them. You see how that has worked? And that's been the case for every single trinomial we've worked with so far in this learning target, in this unit. So now we're going to kind of talk about what might be different going forward. So take a look at the set number 2. When I do an area model for these, I've now got a little bit of extra numbers going around. So this becomes 10x squared, this becomes negative 15x, this becomes 2x, this becomes negative 3. And over here, when I make this area model, I get 6x squared, 7x, 12x, and 14. So what I want us to notice is that, notice in this upper left box, in this here and here, we don't just have x times x, right? We've got a 2 and a 5 here. Same thing here. We don't just have an x and an x, we have a 6x and an x. So this is what we're going to talk about today, is how do we figure out what goes here and what goes here when we have a number that's not just the x squared like it's always been. Like whenever I've given you guys something like x squared plus 3x minus 2, and I've told you to make the area model, you instantly know x squared goes here, and you instantly know that x and x have to go here. But as we go forward, you're going to start to see, well, if I had a 6x squared here, I could have a 3x and a 2x. I could also have a 6x and a 1x. So you're going to start to see that it's not always as obvious what numbers go there like it was in the last learning target. Okay? So let's take a look at some ways we can start to figure this out. So I've got an area model here. And this area model represents the trinomial 2x squared plus 13x plus 20. We want to write it as the product of two binomials, meaning we want to factor it. So I want to know what this thing looks like here. What goes inside here and here. So what I've done so far is I've taken this 2x squared and I've put it in the upper left, and I've taken the 20 and I've put it in the bottom right. Okay? So now I got to figure out what my options are to make sure that I get this 13 in the middle. Right? So I know that the numbers have to multiply to 20. So I'm going to go ahead and write down all my options. I've got 1 and 20, 2 and 10, and 4 and 5. All three of these options will get me the answer of 20. So let's just try doing some guessing here. For 2x squared, I know one side has to be x squared, and I know the other side has to be 2x. Oops, sorry. X and 2x. There's no other combination that will get me 2x squared. Okay? One has to be 2x, one has to be x. Okay? So now I'm going to go ahead and try and make a guess. I'm going to first try and guess 1 and 20. Remember, I'm trying to get a 13, so I'm going to pick 1 and 20. So let's put a 20 here and a 1 here. Okay? 20 times 2x gives me 40x, and x times 1 gives me x. Does this thing give me 13? Nope, it sure doesn't, so I'm going to start over and try again. What about 4 and 5? Or actually, let's do 2 and 20, 2 and 10 first. Let's try 2 and 10. Okay, 2 times 2x is 4x, x times 10 is 10x. Does 10x and 4x give me 13? Gives me 14, which is close, but not what I want. So erase, let's try again. All right, let's try 4 and 5. Okay, let's do 4 and 5. I get 5x squared here and 5x, and 4x here. Does this give me 13? Nope. So at this point, I'm kind of like, well, I've tried all 3 combinations. I've tried them all. Then maybe this doesn't work. Maybe something's wrong. There's not anything wrong, but in this new learning target, the order actually matters. So when I put 5 here, when I put the 5 here, and I put the 4 here, it's giving me the wrong answer. But what if I erase that 4, erase that 5, and what if I switch them around and I put the 5 here and the 4 here? Is that going to change what I do? Well, let's see. Sorry, this should be a 2x here, sorry. So 4 times 2x squared is 8x, and 5 times x is 5x. And now is 5x plus 8x 13x? Yes, it is. So it didn't work when I had the 4 on the left and the 5 up top, but it does work when I have the 4 up top and the 5 on the left. So this is really important that we are recognizing the arrangement of your area model. It's like a puzzle, right? You've got to figure out what goes on top and on the sides to match what's in the middle. Okay? I really recommend treating this unit like a puzzle. All right? So now that I've gotten this set up, now I know that my answer, factoring answer, is, well, one of the binomials x plus 4, and the other is 2x plus 5. Now the order here doesn't matter. I could write this as 2x plus 5 times x plus 4, and both of these are okay. It's the order mattering, like what's next to each other on the area model. Okay? Let's do a few more examples of this, and without giving you that first hint of an area model. So what I'm going to do is I'm going to draw my area model here. Okay. I'm going to put inside the area model what I know has to go in there. I know that a 3x squared has to go here, and I know that a negative 4 has to go here. I know that whatever goes in the middle has to add up to 11. Okay. However, I don't necessarily know that it has to multiply exactly to negative 4 because I've got this 3 in the front that's going to affect it, right? So if I go back to the other example, the 4 and the 5 multiplied to 20, but the 2 here affected how I got that 13. In the same way that this 3 is going to affect how we get an 11 when we also multiply by 4. So there's a trick to this. It's kind of a neat trick. Here's a trick. You're going to want to look for the same way we did the x before, right? I had you guys draw an x, and I had you put the last number up top and the middle number on the bottom. Well, now I'm going to teach you guys a way that you deal with these types of problems. And I'm going to show you. I'm trying to think of the best way to show you this here. So you're still going to do your x. However, now your x is going to have, instead of just having it be negative 4 up top, you're actually going to multiply the first and the last on top. I'm going to call this a times c. Okay? And then you're going to put the same thing before, that middle term, 11, that's going to go on bottom. And I'll rewrite this so it's a little bit easier to see. Remember, standard form looks like this, right? ax squared plus bx plus c. So you multiply the first and the last number, and that goes up top. And then you put the middle number on the bottom. Same thing, the middle number always goes on the bottom. Okay? So let's try this with this first problem. So I'm going to draw my x. So here's my x. Now I'm going to multiply. Negative 4 and 3 gives me negative 12. And then my middle number is going to be 11. Oops, I dropped my pen. Okay? So now what two numbers multiply to negative 12 but add up to 11? That's going to be a positive 12 and a negative 1. Okay? So I'm going to refresh you here. I got this negative 12 because I multiplied 3 and negative 4. That's how I got the 12. The 11 I got because it's the middle number here. And then I just treated this the same way we treated the last learning target by finding that those two numbers that multiplied at the top add to the bottom. Now once I have these, just like last time with the Punnett squares, you're going to take these two new numbers that you found, this 12 and this -1, and you're going to put it back into the Punnett square. Okay? And now you're going to treat this like a puzzle to figure out what goes on top and what goes on bottom. However, there is a very, very nice little trick to help you do this, and that's using the GCF trick. So the first thing I want to point out is that you will notice, I'm trying to get my highlighter here, you're going to notice that this row right here, this 3x and this 12x, has a GCF, right? If I look at 3x squared and 12x, the GCF is going to be 3, and the GCF is going to be x. So there's I know that has to go over there because that's my GCF. Okay? If I know there's a 3x here, then I know this has to be x here. Okay? If I know that this guy is a -1x, I know that this has to be -1 because whatever's on the outside has to multiply to what's on the inside. And if I know this is -1, then I know this has to be +4. So I first just found the GCF of this top row, and then I used logical reasoning to find the other parts. Okay? So now I can write my final answer as 3x - 1 and x + 4. Okay? This guy is what you want to remember. Okay? Multiply the first and the last, put the middle term in the bottom, and then solve the puzzle like before. And then you have to put it in the Punnett square to make it work. Okay? All right, I'm going to show you a few more examples. Okay, I know this is a very new idea, and there's a lot of steps, so don't panic. Okay? Split this up here. All right, 10x squared plus 9x plus 2. I'm going to start off by drawing my Punnett square. This is how I always start. Draw your Punnett square, put your 10x squared here, and put your 2 here. That's all we can do right now. Now I'm going to make my x and solve my puzzle. I'm going to do 2 and 10 to get 20, and then I'm going to put the 9 below. Now I'm going to solve my puzzle. What two numbers multiply to 20 add up to 9? Like I said, if you have to write out your terms here and then figure out which one it has to be. I know 4 and 5 multiply to 20 add up to 9, so it's got to be 4 and 5. Now that I know that 4 and 5 are my middle terms, I'm going to put 5x here and 4x here. Okay. Now I'm going to solve my puzzle. Now in this one, you actually can find 2 GCFs, which is really kind of cool. You can find your GCF. Oops, I did not mean to do that. Let me undo. All right, sorry, I thought I had the highlighter on. We can find 2 GCFs. The first GCF is this guy right here. That's the first one. So let's find that one first. So the GCF of 10x and 5x is 5x. You can also find the GCF of this thing, of 10x squared and 4x. The GCF of 10x squared and 4x is actually 2x. And now you'll notice that if you look at 2x and 5x, don't they multiply to get you 10x squared? So the GCF does work, and it works really well. Now I'm going to use reasoning to find my outside answers. Okay? If I know 5x is out here and 5x is in there, then this has to be 1, because 5x times 1 gives me 5x. And then what times 1 gives me 2? 2. So 2 times 1 is 2. And then of course you can go back and check and make sure all of these works. 2 times 2x is 4x, and this puzzle is a really nice thing to check your answers, right? The puzzle has to make sense for it to work. Once you've figured out the puzzle, now you take your outside numbers and put them in as factors, as binomials. All right, let's do a few more together. All right, and by the way, you're going to have a couple tries on your own, but if you want to stop and try all of these on your own, you're free to do so. All right, so I'm going to put the 8x squared here and the 9 here. I'm going to draw my x, and I'm going to multiply 9 and 8 to get 72, and then put -18 down below. Now I'm going to go ahead and list the 72. I've got 1 and 72, 2 and 36, 3 times let's take out the calculator here. 72 divided by 3. And I've got 24. 72 divided by 4. 18. 72 divided by 6 gives me 12. And there's my answer. I can see that 6 and 12 will work. So I'm going to go ahead and put -6, -12 in my x. Now I'm going to take that -12 and -6 like before, and I'm now going to put them into my Punnett square. -12 and -6. Don't forget to put your x's with it because you're going to struggle finding the GCF now. So now we're going to find our GCF of each row here. Okay, so the GCF of the top row is going to be 8x. Don't worry about that negative yet. We'll worry about the negative later. Don't worry about it for right now, okay? And then the GCF of this top row here is going to be 2x. And that can work because 2 times 4 is 8. So now to get this -12x, I have to put a -3 here, because then 4 times -3 gives me -12. To get a -6 here, I need to have a -3 here, because 2 times 3 is -6. And then if I check the -3 and the -3, does -3 times -3 give me 9? Yes, so my puzzle works and I am done. And I can write my final answer as 2x minus 3, 4x minus 3 as my final answer. All right, let's do one more and then I'm going to show you a next step because there's one more level we have to get to. Okay, so same thing, draw your box. Boom, boom, boom. Put your first term here, put your last term here. Now multiply those two terms, -66 and 5. And then you want to go ahead and write out your factors of 66, 1 and 66, 2 and 33, 3 and 22, and 6 times 11. Now, I know I need a -33, so I know that, a -66, so I know one of these has to be negative and one has to be positive, and I see that with 6 and 11, I can make that happen. If I have a positive 11 and a -6, I can get that 5 I need. Now I'm going to take that 11 and 5 and -6 and put it into my Punnett square like that. And now, just like we did before, find your GCF of the top row and your GCF of the side row. Now here's where it can get a little weird because I look at this top row right here and the only thing they have in common is an x. That's all right. That's going to happen sometimes. It's okay they don't have a number in common. They could just have a letter in common. The side row, 2 and 6x, have a 2x here. So now it does work, right? 2x times x is 2x squared, so it makes sense in the end. And then this guy over here has to be a -3 because I need a -6. And then this guy over here has to be an 11 because x times 11 is 11. Because you're making these logical connections of what has to multiply to get the inside number. Okay? This puzzle works, so I'm going to write it out as x minus 3, 2x plus 11. Alright? Now I want you guys to pause the video and I want you to try these two problems on your own. Okay? I need to see work when you come show me your notes, and if you don't know what to do, please come ask me while you're watching. Alright, these should be your solutions. 2y plus 1 times 3y minus 4, 3c minus 1 times 4c plus 5. Please have your work to show me, or I will not let you go on. Okay. The last thing we have to think about, and this comes back to the very first learning target of this unit, is remember that pesky GCF we always have to look for in every problem. This is the case for this learning target as well. Always, always, always look for a GCF first, every time. So don't in number 1 do this. Don't do 200, 2,400 and -100 down here. Don't do that. Don't multiply the first and last because that's a really big number. That's going to take you like 10 years to figure out. You don't want to do that. I don't want to do that. No one wants to do that. So instead, notice that they're all even numbers. So they all have a GCF. In this case, they all have a GCF of 4, which leaves me with 6n squared minus 25n minus 25, which is a much more reasonable problem to work on. Now, the only tricky part is now when we make our area model, you make it with this, okay? So when I make my area model and I go to solve my puzzle, I'm going to put 6n squared here and negative 25 in here, not 24n squared and 100. I work with this new thing I found. So when I make my x, I'm going to do 6 times negative 25 to get negative 150, and then negative 25 on the bottom. Now this may seem like really big numbers, but when you start looking at factors of 150, it's not so scary. Oops. 1 times 150, 2 times 75, 3 times 50, 5 and 30, and there I see the relationship right there. I can get a negative 25 from 5 and 30 if I make the 30 negative and the 5 positive. So now I'm going to take that negative 30 and that 5, and I'm going to put it into here. Negative 30n and 5n. Now, just like before, find your GCF of the top and your GCF of the side. So my GCF of the top, 6n and 30n, is 6n. The GCF of the side, there's no number in common, but they have a letter in common of n. Okay? And then this has to be 5, because n times 5 gives me 5. And then this has to be negative 5, because 6 times negative 5 is negative 30. And then to check, 5 times negative 5 is negative 25. So all my spaces work. So my final answer is, and this is really important. Are you ready for this part? Because this is important. This guy, this 4, notice I'm circling it over and over and over again. You have to bring it down into your final answer. Have to, have to, have to. Otherwise it's wrong, because that's part of your answer. And then write out your 2 binomials. If you don't put that in your final answer, then it's wrong. It doesn't make any sense, right? So please be careful about that. I've taught this for about 6-7 years now, and this is a mistake I see every kid making all the time. Please put that back in your final answer, all right? I'm going to show you one more, and then you've got 2 to try on your own. So again, always look for a GCF. Does it have a GCF? Yeah, they're definitely all even numbers. I think 2 is the GCF because all the other numbers don't have anything else in common. So I'm going to pull that 2 out, and I get 6m squared minus 16, nope, sorry, minus 17, 17m, and then plus 5. Okay, I'm going to do my Punnett square with this thing in here. So draw my Punnett square. I'm going to put 6m squared here and 5 here. Remember, I'm using this thing. I'm not using the original. Now I'm going to do my x. I'm going to multiply the 5 times the 6 for 30. And then I'm going to put the negative 17 down here. All right? And now I'm going to think of factors of 30 that have negative 17 as its sum. So 1 times 30, 2 times 15. I'm going to stop there at 2 and 15 because I see there is a 17 involved. I know this has to be positive and this negative, so that means both of these have to be negative. Negative 15 and negative 2. I'm going to take that negative 15, put it here, take the negative 2 and put it here. By the way, guys, it does not matter where you put which one. I could have put the negative 15 where the 2 is. I could have put the 2 where the 15 is. It doesn't matter. Your answer will be the same, which I know is kind of magical. Okay. Now find the GCF of the top row and the GCF of the side row. The GCF of the top row, the 6 and the 15, they both have a 3 in them, so n and m, so that's 3m here. The side row, 6 and 2, both of them have a 2 and an m. And now let's just work backwards. This has to be a negative 5, because this is a negative 15, this is a 3. This has to be a negative 1, because 2 times negative 1 is negative 2, and then if I double check the outside, negative 5 times negative 1 is positive 5, so it works. I have to write my final answer though, and like I said, I have to remember to take this 2 and put it back in the front, so I get 2 times 2m minus 5, 3m minus 1 as my final answer. Alright, the last 2 problems I want you to try on your own. Once you're done, please unpause to check and see if you've gotten them correct. And remember, I do check for this, so don't try and cheat. Okay? Good luck, guys. Alright, these are your solutions for the U-try. You should have gotten 4 as your GCF, and then 3a plus 1 times 3a minus 4. And then your GCF for number 4 should have been 5, and then you would have gotten 3n plus 2 and 2n minus 9. I always need to see your Punnett squares for these. You don't have to do the x part. That's completely up to you. I like it. It helps me think about the numbers better, but that's your call. Okay? Please don't come to me asking me how to do number 1 if you do not have the U-tries finished or asked for help. I won't deal with it. So you know what to do. There are a lot of practice problems in this learning target. I put a lot in there for a reason. So it might take you a few days to get this done. All right? Good luck, guys.